Hello. Today we're going to be working on operations with polynomials, and that includes both exponent rules, but then also the operations on the polynomials. So let's go ahead and take a look at some of these exponent rules that we've learned in the past. So if you have a to the m times a to the n, what you're going to do there is you're going to take and you're going to do a to the m plus n. You're going to add your exponents when multiplying. So for instance, 3 squared times 3 to the 5th, that's going to end up being 3 to the 7th for a grand total of 2,187. If you have an exponent with a base being raised to that exponent, and then that's also being raised to an exponent, we're going to end up doing a to the m times n for this one. You're going to end up multiplying the exponents. So a power to a power means you multiply them, which means for these 3 squared to the 3rd power, you're going to end up with 3 to the 6th power, which ends up being 729. If you have more than one thing in the parentheses, but it's still a monomial, notice there's no addition or subtraction in the problem. If it's a monomial being raised to a power, what we do is we can raise everything to the power. So it's a to the m and b to the m. So everything gets raised to the power. And now what we're going to do is take a look at this next one. We have 3 times 2 squared. So we're going to do 2 squared times 3 squared. Notice everything gets raised to the power. So this is actually 4 times 9, or 36. Negative exponents are a little bit different. And you can't have a negative exponent. Anytime you have a negative exponent, you're going to want to move it to try to simplify it. Okay, so in your final answers, they'll never have a negative exponent. If there's a negative exponent and it's in a numerator, that negative exponent then needs to move down to the denominator, and the only thing that changes is that the negative exponent now becomes a positive exponent. Okay, so you move the negative exponents. Now, let's say that you had a negative exponent in the denominator. That negative exponent needs to move from the denominator to the numerator and become a positive. Okay, so if it's in the numerator and it's negative, it moves down. If it's in the denominator and it's negative, it moves up. So this 3 to the negative second, we're going to move it down. It's going to become 1 over 3 squared. And that's going to end up being 1/9. Now, negative exponents with numbers are most often missed. This is the most frequent mistake that I see. Because people look at this and say 3 to the negative second, hey, I can multiply those as -9. But really, you have to move negative exponents down before you try to simplify them. The next one is a lot of people's favorite rule here. Anything to the 0 power is always 1. So with this one, if your exponent is 0, it's going to be 1. So 3 to the 0 is 1. Now you have to be very careful because it's only what is being raised to the 0 power. So if we had 3x to the 0, notice only x is being raised to the 0. It's not parentheses 3x to the 0. These are different problems. So in this first one, only the x is 1, so your final answer is 3. In the next example, everything is being raised to the 0 power. Therefore, that's going to be a 1. Okay, quotient of powers. If you have two different things in a fraction that have the same base, you can go ahead and simplify them by subtracting your exponents. So 3 to the 5th over 3 to the 2nd, we're going to take and say 3 is our base, and 5 minus 2 is 3. So 3 cubed is 27. And the last one here, a divided by b, this is once again a monomial being raised to a power. So everything in it needs that exponent. So a to the m and b to the m. And so this next one here, this is going to be 2 squared and 3 squared. So it's going to end up being 4 over 9. Okay, so those are all of the exponent rules. I know we went through them in a flash. We're going to go ahead and take those rules and put them all together to start simplifying things. There are 4 different things to simplify a monomial completely. You cannot have any powers of powers. So you should never see something like x squared cubed. There can't be a power and a power. Each base only appears once. So for instance, if you had x squared and x to the fourth in a problem, that doesn't work. You also can't have x squared and x squared in 2 different fractions that are being multiplied together because that base appears once. We can continue to simplify. All fractions are in simplest form, both with your variables and with your numbers. So for instance, 4 over 12 would have to be reduced. And then the last one, there are no negative exponents. So if there is a negative exponent, it has to move, and then it becomes positive. So let's go ahead and try some of these. So simplify each of these completely. Number 1, there's a negative exponent, that -2. That has to move because it cannot remain where it is. So what we do is we circle the term that has the negative exponent. In this case, it's just the x to the -2. We're going to leave the 3 alone, and we're going to bring the x to, we're going to bring the x to the second power down into the denominator, and the -2 becomes a +2. This would be our final answer. So the next one, 2/3 to the -3. What we're going to do is we are first going to raise everything to the power. So 2 to the -3 over 3 to the -3. Then we're going to say this 2 has a negative exponent, this 3 has a negative exponent. We're going to move them. So it's going to become 3 to the +3rd and 2 to the +3rd. Once we rewrite them, now we're going to actually figure out what those equal. So that's going to become a 27 over 8. Number 3, 342 to the 0 power. This is all being raised to the 0 power, so everything simplifies to 1. Okay, so now we're going to put a couple things together. We're going to start ramping it up a little bit. Okay, so for number 4 here, we have 3 different bases. We have -3, x squared, and y cubed. Each of those is going to be raised to the 5th power. And so we're going to do -3 to the 5th. We're going to do x squared to the 5th. When this happens, we're going to end up multiplying those. So it's going to be x to the 10th. Y cubed to the 5th, what becomes y to the 15th. And then we're going to actually evaluate -3 to the 5th power. It is -3 times itself 5 times. So that's going to end up being -243, x to the 10th, y to the 15th. That would be our final answer. Okay, this next one, there's many different ways to do this. We can go ahead and, since everything is in a fraction, you can either raise everything to the power first, or you can reduce things first. I'm going to go ahead and just raise everything to the second power first. Okay, so we're going to do 2 squared, x to the 6th, y to the 2nd, over 4 squared, x to the -4th, and y to the -4th, because remember, we're multiplying the exponents. Then what I'm going to do is I'm going to circle all negative exponents, and I'm going to move them. I'm also going to figure out what 2 squared and 4 squared are, because those ones are not negatives or anything. I can actually figure those out. So 2 squared is 4. 4 squared is 16. I have x to the 6th and y to the 2nd that I did not move. Then I'm moving up x to the 4th and y to the 4th. So I distributed my exponents, I took care of my negatives, and now all that's left is just combining and simplifying. So the first thing I noticed is that 4 over 16 can reduce. So I'm going to go ahead and take and reduce 4 over 16. That's going to become 1 over 4. I also notice I have 2 different x's here, so I can actually take and add my exponents together. So it's x to the 10th. Same thing with my y's. So I'm going to go ahead and take and add my exponents together and get y to the 6th. This would be my final answer. Let's go ahead and use that same process for number 6. So the first thing I'm going to do is I'm going to raise everything to the -2nd power. So 3 to the negative second. Negative 2 times negative 2 becomes a positive 4. So it's a to the positive fourth, b to the negative second, over 2 to the negative second, a to the negative eighth, and b to the positive 10th. So step 1, raise everything to the power. Step 2, identify everything that has a negative exponent and move it. Notice I'm including the numbers here. 3 to the negative second has to move. So with my new fraction, I'm going to rewrite everything that stayed where it was. A to the fourth did not move, and b to the 10th did not move. 3 to the negative second moved down and became a positive second. 2 to the negative second moved up and became 2 to the positive second. B to the negative 2 moved down and became b to the positive 2. And a to the negative 8 moved up and became a to the positive 8. Now it's an issue of simplifying things. So 2 squared is 4. 3 squared is 9. I have my a's that I can combine to get a to the 12th. And I have my b's I can combine to get b to the 12th. And nothing else reduces, and each base only happens once. So that is my final answer. Oops, sorry. That is my final answer. Okay. Taking a look at 7, 8, and 9. So looking at number 7, you have fractions. So when we multiply fractions, we're actually going to multiply across the top and across the bottom. So 3 times 6 is 18. X times x to the negative third, this is x to the first power, and x to the negative third. We're going to add those together to get negative 2. Y to the fourth times y to the second is y to the sixth. 2 times 4 is 8. I have 5 x's and 2 y's in the denominator. I'm going to move down my x to the second, and I'm also going to reduce 18 over 8 by a factor of 2. That becomes 9/4. So this becomes 9y to the sixth over 4 x to the fifth y squared, and then I moved down x to the second. So now I have my y's that I see I have to reduce and my x's I see I have to combine. So I have a 9 in the numerator. Y to the 6th over y squared, I'm going to subtract my exponents to get y to the 4th. And in the denominator, I have the 4, I have the x to the 5th and the x to the 2nd. Overall, I'm going to add those together to get x to the 7th. This would be my final answer. Okay, for the next one, I'm going to raise everything to the negative second power. So it's negative 5 to the negative second power and x to the positive 4th when I multiply those together. I see this negative 5 to the negative second power has to move. So it's going to become x to the 4th over negative 5 to the positive second power. Notice that only the negative exponent changed to positive. That's the only thing that we had to change when we move it. Now when we simplify it, we get x to the 4th over negative 5 squared becomes a positive 25 at this point. This would be our final answer. And then for our very last problem here is going to be this one. It is an issue of reducing and everything. So for this one, we're going to reduce 6 over 36. 6 divided by 36 is going to be 1/6. I have a negative 1 in the top, a 6 in the bottom. For my a's, I'm going to look strictly at these ones. I have 4 a's on top and 7 on bottom, which means that 4 of them are going to cancel out, and I would have 3 a's left over. And the a's that would be left over would be on the bottom. So there's going to be a cubed on the bottom. Now I'm going to do the same thought process for my b's. I have 1 b on top and 2 b's on bottom. 1 b is going to cancel out, and I'm going to be left with 1 on the bottom. And for my last one, c's, I have 8 c's on top and 1 c on bottom. 1 c is going to cancel out, and I'm going to be left with 7 more on top. This would be the final answer. For the next section with the operations on polynomials, go ahead and try it on your own first, and then I'll make another video only if you need it. Okay, so don't watch the next video unless you need it.